context that relates to one microservice, which relates to like one deployment unit. Like pretty standard, pretty straightforward, easy approach. And to be honest, in the beginning we thought this might just last for the first 6 months or so, and then we changed this a little bit. But until this day it's still true, and it kind of helped us along the way. And I will show you a couple of examples where this approach helped us a bit. After looking at the app and what I explained to you around the use cases, you can probably derive like at least 4 microservices or bounded contexts or domains that we need to, or that we designed from the beginning. One is, we call it the charge point. So that's like the search and find API that you have. Like this is a search index that has all the charging stations, whether you control them directly or whether they come through an aggregator or something. So that's one service, one deployment unit with a database that just has all the charging stations at hand that can just give it through the API for consumers. The other part to this is like all the charging stations that we physically connect to our backend, that are connected, for example, through SOAP or WebSocket, JSON, we handle in this ChargePoint operator service. So that one is really responsible for like doing all the physical connections with the charging stations, all the management of the physical stations, like software updates, firmware upgrades, all these responses to like really commands that the station send to us that we need to respond and all of that. So this is this service that takes care of that one. And I mean, for example, when you configure a new station in our system, it's first of all, it's directly connected to this service, but then once it's there, so to speak, once it's ready to be used, it will be pushed or it will be fetched from the ChargePoint service, so from our search index, to be able to be used by external services or by our app. Another part is like all this customer domain that we have, where we manage contracts and customers and subscriptions and maybe tariffs and all of that. So that's like clustered in here in this domain service. And the other one is energy management. And in the energy management, the energy management service doesn't really care so much about the charge point itself as like a physically connected device, but more like a power consumer. It maybe has some limits. Maybe it's like inside the garage, inside the basement, and it's not the only charging station there, but there are 5 more charging stations. So they need to balance the energy a little bit, so they only need to like control the profiles that these charging stations get to charge the cars. So you see there are different angles on, mostly it's around charging stations, but everyone has a little bit of a different twist to it. And I mean, of course you can just probably write all of this in one service, but for us it was in the beginning a little bit tedious, to be honest, to shape it this way, because there's quite a bit of overlap, especially if you think about life cycle steps. So the charging station, for example, in the ChargePoint operator has a certain life cycle, and it has a different life cycle in the search and find ChargePoint domain. So we had to model all of these different life cycles inside these services also. And that obviously was a little bit of complexity that we had to add.
Sorry, I'm just wondering what the exact reasons were for splitting up the charge point and the charge point operator. Mm-hmm. This seems to be part of the same bounded context. Mm-hmm. I'm just wondering what your thinking was there.
Yeah, what we saw being added in the operator, so in the connection of the physical devices, was all this protocol handling. And every station, almost every station, brings their own model to it. So one of the stations in their protocol that they define, which you can't change, they say like, our station is called a spot. And the next one says like, yeah, but we only talking about connectors and all of that. So there was a lot of different languages involved and all of that. So we said, let's separate this into this service. Let's also move all of this hardware related, like updating stations and all of that, into this. So we can here just focus on getting charge points to consumers very fast. because that one doesn't just fetch all the charge points from this service where we manage our stations ourselves, but also from aggregators and so on. So that was our reason to split them. So when we look at like one of our distributed application with its domain services inside, we weren't living on like our own little island. We had to integrate with a different couple of different services, and that also is kind of part of my answer that I just gave you. So we didn't want to implement an authentication provider ourselves, so we used Auth0 for that one. That one we had to integrate. We had to integrate with our apps, the mobile apps and the web apps. We had physical stations that connect to our apps and not to our application, and not just one, but like many of them. We have these aggregators like Stadtwerke München that provided stations and so on, and third-party backends. And as I said, every one of them, especially the aggregators and the other third-party backends and the physical stations, they all spoke their own little language. And we were really afraid of like having a different language creeping into our domain, especially the search and find service. We wanted to have really clean. So that's why this was a challenge. And we had this challenge actually from day one, and maybe that was an advantage for us because we feared this already so early in the process that we said we should probably split it, even though it is more work.
Why didn't you use ACLs, like translation layers between your domain model and the externals?
You mean? Good point, that's a good bridge. Because that's what we did at the end of the day, or from the beginning. So we thought like good fences make good neighbors, and we really want to like integrate with all these different aggregators very well. So we thought about exactly what you said, like we have these other services or physical station that we want to integrate, and obviously if you are the one calling them or they call you, it's like this model, this language that kind of creeps into your own distributed application, into your domain. And we said obviously very fast, we need to have an ACL, some kind of anti-corruption layer. And we had this, and we modeled it, and very fast. And that was kind of a strange situation because I was kind of the architect helping the team designing it, and you know we had a lot of sessions around domain-driven design and how we split the domains. And then it happened that while developing actually inside the IDE into IntelliJ, we realized that if we have the ACL being part of this domain service here, it's just so easy to just jump over the ACL and just maybe call the service directly, or being called directly by the other services. So we said we even need to go one way further down the chain and move the ACL, making that an adapter, separating it out into its own service, into its own deployment unit that lives inside its own Git repository. And I mean, it looks a little bit over-engineered. And we stared at this at the whiteboard in the beginning for like 2 hours and said, like, should we really do this? This looks lots like we are going to add a lot of services just for this. But we did it, and I think it helped us, especially in the beginning, to not jump over it and to have like the language really being well defined. On the cons, of course, this is a deployment unit that you have to pay. This is one you have to pay. So you just doubled your costs per service basically, or at least per integrated third-party API. But nevertheless, we adapted this pattern throughout our entire microservice architecture. So whenever we integrated with another external services, we always had this adapter in between that just translated between the two languages for us.
How do you keep people from using the domain directly rather than going through the adapter?
It's probably a little bit easier to just to have this in place, kind of governance in place, because if you look at the deployment stages and at the infrastructure as code and the repositories, to use this physical station here directly, you have to have some configuration in this service to be able to call it. Maybe authentication, some keys, or at least a URL. So it's kind of easy to spot it. at least in your infrastructure repository. But of course, there's always this possibility. So that's kind of how our application looked like. So we have our domain services in the middle, and then we have all our adapters that communicate with the outside a little bit around. Looks a little bit like this onion architecture. And there are two services on the top, and for that one we use this, backend for front-end pattern for two of our applications that we control. So the mobile application as well as the web application, which is a React app that also exposes some API for the browser. So we had this there also being able to translate from mobile to our domain services and from the web application to our domain services. And that was a little bit tedious, I must say, because most of the time it is just proxying through, except for certain cases where, for example, you have one page where you not just display maybe a contract, but also the details of the station, like a firmware version or something of that station where the customer has this contract for, and then it kind of fetches all the information from these services. Still not perfect, I would say, but I haven't really seen any other way of doing this better. So, of course, this backend for frontend calls multiple services, even though it's just one service called from the outside. But that was a compromise that we really didn't have another solution for it, and I think it's totally fine. The only downside or the only risk that you face with this one is putting too much process logic into these backend for frontends. Updating a customer inside your web application, that means updating this and updating that service, and then you need to have compensating actions because you can't have transactions across domain services and so on. So that's a complexity that you get with this approach. But diving one level down into the services, one assumption that we also made quite fast is that each domain service, each microservice has their own data store. So we just use a PostgreSQL because, especially for our search index, we needed to have some latitude, longitude, location-based querying that goes fast. So we chose PostgreSQL. They are Spring Boot application, all our microservices, and we use Gradle to build them. So that's the introduction. So that's how our architecture looked, maybe from a 30,000 feet point of view, and how our product looks like. And now we want to go through a little bit into the details of how we actually make this happen. So how do we build and package the software? How do we deploy it on AWS? How does our infrastructure look like? Especially with these questions, where does my general infrastructure end? Where does my application-specific infrastructure start? And what are actually the infrastructure, or what are the components of the application itself? So that was a question that we had for quite some time. It was a challenge when we moved to AWS. And then obviously how you deploy then an app and not just your infrastructure. So very quick and fast, I guess that's something that a lot of people these days use. We use Gradle to build our Spring Boot application. It will be packaged inside a Docker image. Our entire microservice, which is a deployment unit, unit testing and QA is being done, at least from a code perspective, with Sonar Cloud. So that's our first step in our CI/CD pipeline and the end result from the build, test, and package step. So what do we do then with the Docker image?
Yeah, that's actually a good question. The question for us is, how can we bring this Docker image that Steve just built really into the cloud? How can we put the microservice in action? And as we said, we are working on AWS. So my first question would be, how many of you are working on AWS? So about 70%, perhaps. So you might probably be able to understand all these concepts from the beginning, or you already know them because most of you are more experienced than me. But for all the other people that are not working on AWS, I think it will be really interesting now. So if we want to put our microservice into action, first of all, we need some kind of container service. So in my ideal world, I want to have a container orchestration service where I can simply put my Docker image to and say, please run the following amount of instances, and I will never care about these instances again. Or at least until I will deploy a second one or a third one or a new one. And this is one of the services or one of the key infrastructure resources that we need. We need some kind of hosting. If we have multiple instances, we probably need load balancing between these instances. So this is also one of the resources that needs to be there before we can put our microservice in the cloud. Obviously, we do not want to store our secrets in code, because if they get to the Bitbucket repository or wherever, not a good case. So we need some kind of secrets management. We need to fetch these secrets when the application starts, and maybe also some configurations that we want to have as environment variables. Obviously, what Steve said, we need a database. Perhaps one database or multiple databases, but this is, as we are writing stateless microservices, the state is stored in the database, so if a customer starts charging at a station, he wants to see a session in his app, so he wants to see, I'm currently charging, and this needs to be stored in the database. Inter-service communication in the microservice system can be done by HTTP, but queuing is also a pretty cool solution for that, and we want to use queuing because we do not want to care about some messages. We simply want to put them on the queue, and the listener of the queue can then process the message. I'm not interested in as publisher sometimes. And not last, but also not least, we need some kind of logging. We as developers, we want to look into the matrix, we want to see some green logs there, and obviously this is one of the necessary resources. Where can the logs of the application be forwarded to, where can they be stored, and how can we access them? So these are more or less the infrastructure resources that need to be in the AWS cloud and the system before we actually can put our microservice in action. So the question for us is, how can we create these resources, and how can we maintain these resources? And a good solution for that is AWS CloudFormation. So we can write our infrastructure as code, and when we have some changes, we simply rewrite the template or change the template, and it's pretty cool because CloudFormation uses this template and creates a stack of resources. And the cool thing with that is also that we have everything documented, that we have to do more or less no manual steps, or sometimes we have to do a small manual steps, but most of the things are automated. We can simply shut down the whole application and start it again in 1 or 2 hours, and that's pretty cool. So let's take a small look at an easy example. We can, for example, create an ECR repository where our Docker image is stored, the Docker image that Steve just built, and from where the image is then pulled when the application should start. So here is a small template. I think 70% of you probably know something like that. At least if you're using IntelliJ dark mode like me. And you can see here that we have this nice parameter here. And this parameter is the repository name. So if Steve has built a customer, for example, then there would be the name customer. And in the second part here of this small script is the resource. So it's just the template of our ECR repository. And the cool thing is now that we can use this small template for every application, and then we have for every application an ECR repository. So that's pretty cool. But the thing is, it gets a little bit harder if we want to integrate our microservice into the whole infrastructure that is already there. Because then we have some connections to perhaps already existing infrastructure. We have to import some values. And yeah, that's the point where the whole infrastructure as code concept becomes a little bit complex. So what Steve didn't say, that in our CI/CD pipeline, on the pipelines, we are not using the default Docker image that you get there. We have created a custom image for us in which we can store all our scripts, all our templates for AWS, some bash scripts, and so on. And there are also some tools that we have there in the Docker image. One thing, so it's in the Docker image that is used in the Bitbucket pipelines. It's the AWS CLI, which is a small Python package that you can use to create, to update, to delete, or whatever your resources on AWS. And we do also use a small npm package, which is called SFN create or update. I will come to that later. And as I said, it's pretty cool because we can share all our scripts inside this Docker container in which the Bitbucket pipeline runs. And this is also pretty, well, we need this because in the second step here, in the infrastructure step, we built the infrastructure for all our applications. And there we do not want to have one template specifically for one application. We want to have one template for all our applications and just put different parameters inside. So what you can see here is the bigger infrastructure, the bigger picture. So this is the infrastructure that has already to be there before one application can start and before we can build the infrastructure resources of one application. You can see that we have here all these stacks. Every stack has its own template, and they are ordered in a master, how do you call it, master stack and nested stack way. So the master stack contains all these nested stacks. And of course we have some networking. We are in the cloud and we can build our own VPC or virtual private cloud. We have there some public subnets, some private subnets, and so on. The hosting stack is perhaps the most interesting stack here because this is where our orchestration service lives. We're using ECS there, and yeah, there are also the load balancers and so on. And then of course a database and queuing, as I said, and we're using the AWS Secrets Manager to store our secrets of the application. And last but not least, there is a small Bastion host. It's simply an EC2 instance which we can use in order to be able to SSH inside our system more or less because the applications are running in private subnet. They are not accessible from the internet, hopefully. So we have some challenges if we want to create our infrastructure in that way. And one challenge is that the same thing that we have with our Java code, we do not want to store the passwords of stacks inside our CloudFormation templates. So if you look, for example, there is a database, and this database definitely needs a master password. And how can we bring this master password to AWS? If we write it in the template, it's probably not a good solution. But that's a thing that I showed you with the parameters that we can inject in our templates. So we can simply inject the passwords as parameters in the templates. And what we are doing there is we are using in Bitbucket account variables where we store our passwords and other configurations, and they will then be injected into the templates, and the resources are created on AWS, which is pretty cool. Another thing is that there are some resources that need to be manually created. For example, the Bastion host probably needs an SSH key pair. And in order to be able to create this key pair, we need to go to the AWS console in the browser and to create this by hand, because this is something that you can't create in a template, or at least as far as I know now. And these resources that you need to create by hand may be necessary in the stack. So if I create an ECS instance as Bastion host, I need to say, hey, the following key pair can be used to SSH on the EC2 instance. So this can be done exactly like with the passwords. You just create your resources by hand, then you copy the identifier of the resource, store them in your Bitbucket account variables, and inject them into the template. So that's a pretty straightforward solution. One thing is, the whole infrastructure here is in one Bitbucket repository, or in one Git repository. And there is a pipeline which runs when I make some changes, but the first time when I run this pipeline, the whole infrastructure is created on AWS. The problem is, I make some changes. For example, I think there should be an additional secret in the secrets manager. Now we are in the position that we need to update one of these stacks. And that's pretty messy with the AWS CLI, and there comes this small npm package into the game that I showed you, this CFN creator update. So we can simply use this npm package, and it's doing the work for us. It has a nice function which is called create or update. I think that's all that this package can do, and yeah, it does it pretty good. So these are some of the challenges that we had when we created this whole stack, this whole master stack here. Here you can see a small picture of most of the resources that we are using, and for these 30% that are not working on AWS, there's a small introduction here. So the outer rectangle that you can see, this is the AWS cloud. And the thing is now that on AWS you can have your resources in a data center in Virginia, you can have your resources in Frankfurt, for example, or you can have them somewhere in Ireland. And we decided, as most of our customers are living here in Europe, that we want to be in Frankfurt. And this is the reason why we are here in this one inner rectangle in EU Central 1. This is basically Frankfurt. But AWS doesn't only give you the opportunity to be in one region, they also have different data centers inside this region. And these are these availability zones. And as we are building a redundant system, so we have at least 2 instances of the most microservices running, we probably want to have our microservices in different availability zones. So if there is this major earthquake or big flood or whatever, aliens arrive here on the Earth, they will hopefully only destroy one of the data centers, and the other one will still run, and our customers are able to charge on the stations. One thing that I want to mention here is that we have these public subnets and these private subnets. And as the name says, the public subnets, the resources which are there can be accessed from the internet. The private subnets can only be, the resources in the private subnets can only be accessed through our Bastion host. So there is this big rectangle here, the auto-scaling group. There are all our computation instances, our EC2 instances inside. And there is this Elastic Container Service which manages these instances. So if our Docker image that Steve just created comes, the Elastic Container Service will ensure that it gets executed on one of these instances. So perhaps let's take a deeper look into this, because this is more or less one of the most critical things in the system. So ECS with EC2 instances is the concept that we are using here. And the cool thing is, if we create a Docker image of one of our microservices, we can create a task definition, and this task definition simply has some properties like how much CPU should we use for this microservice, how much memory should be used there, and of course, which is the Docker image that should be executed there. And the concept is now the following, that you can create a service for these tasks and say, okay, the following service should have the following amount of the following tasks. So after we created this task definition, we create a service definition and say, please have 5 instances of our customer service running. Please place them in different availability zones, and that's pretty cool. And the cool thing is here as well, that we can say one service is one target group for the load balancer. So if a request comes into the load balancer, it knows, okay, if it's slash API slash whatever, this goes to, for example, our web backend for front end. If it's something other, like slash my awesome station, I go to the my awesome station adapter, for example. So here's a pretty cool connection between defining a service and connecting it to a load balancer. And as I said, all our instances are running in an auto-scaling group, and the container orchestration service will then place our Docker images inside this auto-scaling group on EC2 instances. Well, the problem is now we have a cool orchestration service and all our instances are running, but they should be able to communicate between each other. And what we are using there is that we have 3 steps. The first step is that that an application that starts registers itself, or the service registers itself at Route 53 with a host name, which is called service name cluster. So if it's the customer service, it's customer.epower, for example, and if it's a charge point service, it's chargepoint.epower or something like that. It registers this host at Route 53, pointing on the internal application load balancer. So we have an internal load balancer and an external load balancer. And the ECS service also registers itself at the internal load balancer, saying, hey, I'm the service, please, if there comes a request with chargepoint.epower, forward this request to me, or balance between my tasks that I have, my 2 or 3 tasks. So now we are able to forward requests that are created in our system to the right service and to the right task. The thing is, there are some services that should be already also connected to the external load balancer. Because if we use our app, for example, the app makes some requests like, hey, give me all the charging stations, and that's definitely a request that should go to the mobile backend for front end. And the thing is that these services can't be added to the external load balancer in one step. This is, I don't know why, but it's not possible with CloudFormation. So what we do there is we create a Lambda function, and this Lambda function does the job for us. It registers the service at the external load balancer, and if the cluster gets updated, or the service gets updated, the Lambda function runs and is doing it again. This is also something that made us sweating some time, because when we made a bigger change in the infrastructure, we had to delete all our services and restart them again and create them again. And the problem was we can't access our system from outside, because this Lambda function only runs the second time. So the first time when you create the Lambda function, it will not run, only if you update the service again. So we were sitting there for half an hour and thinking, oh my God, what's happening here? We can't access our system. It was pretty cool. Yeah. So the problem is, if you look at this picture now, our service may be connected to the load balancer, and we know if we use the following URL, we will be forwarded to this service and the task. But the problem is, our microservices don't know the URLs now. They don't know the host names of the other microservices. So we need to inject these. One possibility is that we simply hard code them in our code, but that's, or whenever you think about should I hard code this, you probably should not hard code it into the code. And the thing is that we are doing here is we store them in the AWS Secrets Manager. And now our applications, when they start, can simply fetch the data from the Secrets Manager, and then they know all the URLs, which might not be a secret, but it's a configuration, and then they can use these URLs to call the different other microservices. In order to be able to access the secrets in the Secrets Manager, we need to create a role for every service, and we need to add the permissions for the different secrets to this role. So not every microservice should be able to access all the secrets. So for example, one of the adapters should not be able to connect to the database. This database password might also be stored in the Secrets Manager. It's better if this microservice only knows the URLs of the microservices around it and not the database password. So we can add to the role all the different permissions. One permission that we leave for every role is that the microservices should be able to see all the secrets, but they should not be able to see the value of all the secrets. But this is pretty cool. We can use here, we can work here on a pretty detailed level. We can say, okay, you can see the host names of the other microservices, but you're not able to see the database password, for example. Yes. So we are now in the position we have created our infrastructure. We have created the infrastructure. Yes?
A quick question. So you guys were using ECS and then rolled your own service discovery, secret management, and load balancing. Did you at any point consider Kubernetes, which basically also is available as a hosting solution on AWS and comes with these things included?
We thought about this a long time, but the problem was the following. Last year we were running on a different environment. We were running on a Cloud Foundry environment, and as in most development teams, perhaps times changed, and the cooperation on which we were, so the cooperation ended on which we were running, so it was an external partner, and we had about 3 months for the whole migration. And nobody in the team actually had worked really with AWS. Some of us had tested some things, one of us had worked for a half year or so in a project, but nobody had really worked with it. And we were in the position that we had to find a solution where all the people in the development team can work with, and where the complexity is not high, is not so high. And after a longer search, Steve came to the result that this might be a good solution, and we discussed it in the team, and we said, okay, that's a good solution, because by using, for example, Kubernetes or hosting your own Cloud Foundry also, the complexity is just too big. And nobody in our development team was a real DevOps guy.
So are there plans to move forward and to change this?
Yes, in July we will have our own DevOps guy in the team.
No, not that, but moving to Kubernetes, for example.
Yeah, and that's the thing that I wanted to say. We have our own DevOps guy in July, who has some experience, and then he will have a deeper look on the whole infrastructure, and maybe we will move to it, maybe we will leave it as it is. It's then a question of effort versus what do we get from that.
Otherwise, Kubernetes might not be the ultimate. If you have your own DevOps guy, still shy away from Kubernetes. You need to solve your business problems and not tag on more infrastructure.
Yeah. So that's also the thing for us. We are all with developers. Now we have some experience with AWS, but we feel more confident, more comfortable in writing Java code or React code or something like that. So yeah. But thanks for the question. Yeah.
What was your base image for your Docker files? Which Linux distribution?
That's a good question.
Wasn't it Alpine? I think some of the Alpine derivatives.
Yeah. We have one guy in our team who is pretty good in Docker because he's doing this more or less his whole life, and he did So yes. So We have created our whole infrastructure. We have created our smaller infrastructure components for the apps, and we have created our Docker image here. And now we are at a place where we can press the red button and we can start the real deployment. So what we do is we use the AWS CLI and we force the deployment of the service. But one thing that I forgot to mention here is before we actually have to push the image to the new created ECR repository. So yes. And yeah, pressing the red button means simply triggering a new deployment for the service, and this means that the ECS service then places the new tasks with the new images and removes the existing ones, and there is some pretty standard AWS configuration there. The tasks get placed on different availability zones, and while deployment we allow 200% of the instance count. So if we have 2 instances normally running, then we get 4 instances running. Yeah, and now the application is running, and that's pretty cool. But the problem is we need to get these secrets and these configurations. And we have some different sources for the environment variables, for example, the application YAML, some system environment variables, or the property source, as it's called in Spring Boot. And the thing is now we need to access the secrets in our secrets manager, and we need to fetch the data from there. So this is something where we have our own utils Java package, which is in all our applications, and when the applications start, they go to the secrets manager and they just fetch the data. And then they set them as environment variables, so there are the different URLs for the internal communication. There are some Spring Boot admin secrets, so that we can use the Spring Boot admin service, database credentials, Active MQ credentials, and some other configurations and other secrets. And now, if the application is running, we need, of course, to monitor it and to look into the logs. What we are using here, which might not be a big surprise, is we're using CloudWatch, which is pretty cool. For some of the services, we have some nice metrics there. If we want to go, if we go into our browser on the AWS page, you can see, for example, the CPU of the database and all these nice little graphs. And they actually really help us also. If I think back one week ago, the database was always on 80–90%, and we were thinking, oh, what's there? And it was just one single line of code that was wrong, as always. And yeah, then we have this Spring Boot admin service. It's a whole own microservice inside our application, which is pretty cool. We can change there, for example, the logging level of the different applications. The applications, simply when they start, they register itself at the Spring Boot admin service, and we have the possibility to look what's happening there. And we are using Prometheus more or less only for the business logic, I think. So if there's, for example, a job running that calculates all the energy plans that we distribute to our charging stations so that people are charging smart in the night, this gets some kind of logged. So was the job successful, or was there an error, an exception, and all these things are forwarded to Prometheus or around, I don't know. And yeah, that's pretty cool. And of course we use Grafana, and we are able to see all these nice things from Prometheus or from CloudWatch from there. Basically, that's our application that is running, hopefully. I didn't test it. Yes, that's it. Thank you. Yes.
So why do you fetch secrets at runtime rather than build time, and what would be advantages and disadvantages of either?
Just wait a minute.
So you mentioned that you fetch secrets during runtime. I was wondering what would be advantages and disadvantages between doing this at runtime versus build time. I just put it in the environment of the Docker container.
Yeah, good point. Initially our idea was that we package that we have our Docker image just being done once, and then we have it in the repository and we can just use it at different environments and don't really need to reconfigure anything or inject some environment variables in the Docker itself. So that was kind of our basic assumption in the beginning, and that's why we looked into opportunities to just fetch secrets when the application starts. Of course, you also get the advantage of if you roll a secret, for example, or if you change a secret, you just need to kind of restart the app and it fetches a new secret and so on. And also a little bit with permissions, if you change permissions at runtime, it also catches these issues a little bit better, at least in our experience. And we never really had an issue with fetching these. This was a little bit difficult in the beginning to set this up, because these Spring Boot fetching property sources from the secret manager is not something that's like built in and and at your face in the beginning when you look at this. And also setting up the permissions was a little bit tricky, but once we had this all set up, it gave us a nice process that was, and that's very important for us, written as infrastructure, as code in a Git repository.
Could you tell us what are the challenges you met? Could you please tell us what are the challenges you met? The ones that tend to take a little bit, cycles to resolve, and how you solve these things. I mean, it seems like a very good plan, but surely there are things you thought initially that was one way, and then it was implemented in different ways.
Yeah, I mean, there were a lot of challenges that we faced. One thing that we haven't mentioned actually, but the team was, so I was just acting as an architect, and there were like 4 or 5 developers, and that was the entire team responsible for this whole setup of the AWS infrastructure as well as the code. So we had like limited resources, and one challenge that we had was like monitoring. Monitoring was a bit of a challenge for us in the beginning, because in the previous setup we used the Netflix stack with Eureka, and Eureka works quite well as a service discovery, service registry for Prometheus. So that was a little bit easier back in the days to set up Prometheus to like fetch all of these matrices from the different services. So that was something that we struggled a little bit with, and also having 2 separate load balancers, like the internal and the external load balancer, and having ECS being registered at both for certain services was a challenge for us. And that's where we had to come up with the Lambda function that keeps both target groups and things that are connected to the load balancer. That was a challenge, yeah.
And one thing where we had a lot of discussions is actually where does the code end and where does the infrastructure begin. So we didn't know how can we come to a result where we do not have to write all these templates for every service, and how can we actually share these templates between our services. I think it's something, now when we have the system, it feels good, and we know, okay, that's how you can do it, but we didn't know it in the beginning. Yeah. And one thing that we only mentioned on the side now in this presentation is we had this system already running on the Cloud Foundry environment, and we had to do this migration, and we didn't want to do the migration in one day and shut off the system and start a new one, because we wanted to test it before, and we wanted to have more migration step by step. And what we did therefore is that the first step that we did was we created a database, and we brought all the data from the running system in the new system and connected the services that were running on Cloud Foundry with the database. And that's also the reason why now the database is in a public subnet, because we had to access it from the other system. But now it's also pretty cool to have it in a public subnet. You just add a security group and you feel like it's safe, but that's also something that we might probably change in the future.
On one of your slides.
1 second.
Okay, sorry. So on one of your slides you also mentioned Aurora, and you said you're using Postgres. So what you are using Aurora for? And do you use Postgres RDS or on your own EC2 instance?
No, what we are using is Aurora, but we're using Aurora with the PostgreSQL language.
Okay.
And the cool thing is it's a managed service, and we have all these backups and so on. Our approach is to have as less infrastructure that we have to run ourselves and to have as much managed services.
So this answers the second question as well.
Mine is a follow-up to that question. With the Postgres flavor of Aurora, and you're using the spatial extensions, are you finding you get full support because of Postgres 10, now 11? Are you getting all the extensions supported? And I ask that because we're using Postgres natively, not in Aurora, so for me it's a personal interest if you successfully use things like foreign data wrappers or some of the other extensions.
To be honest, I think we're pretty basic PostgreSQL users there, and I don't know, do we have one? I think we have one extension,
one function we need.
One
That's
function
all we
which calculates the radius of a station. So if you're in the radius of a station.
So it's PostGIS extension.
Yes, yes. So we have no external extensions.
In your stack, deploy, this infrastructure, when you were creating a template for infrastructure deployment, you said like there is for each service you have a logging system or a Postgres database that is only for one service, right? So, how do you handle the overlapping relationship between multiple microservices if you have only one single database there, the database in each service? How do you handle the overlapping relations there?
So I don't know if I made it clear. We're using one Aurora database because, to be honest, our system is not that big that we need to use multiple databases there. We're using one Aurora database for the 5 or 6 services that need a database, and inside this Aurora database we create sub-databases. So, and each service has only access to its own database. It has its own user, or it has its own user and its own password, so there can't be any problems between this, like connecting to the wrong database.
One more thing is like when you say you have these charge point operators, there you have a multiple different environment that you have to deal with. And you said now that you also use Prometheus for actually getting the matrices about the uses of charge point. How do you, because Prometheus needs a collector in each location, how do you handle like this different environment for that collection there? Like, do you have a different collector for different clients, or do you have some kind of other solution there?
The thing is, the charge point operator itself it's one of the bigger microservices, let's say, and it handles all the logic for our own physical stations, but there are connectors around this charge point operator. For example, there is, I don't know if somebody of you has some knowledge about charging stations, but there is a protocol which is called OCPP 1.6, and you can, this basically runs on a WebSocket connection, so we need to have our own WebSocket server, and this is one of the adapters that is outside the charge point operator. Or there's the other station that has a pretty native, that has a protocol which is called HL one-way. It's something that you can absolutely not reuse somewhere. It's something that is also not so compatible with OCPP 1.6, so it's in an own adapter. Does this answer your question? Because I didn't understand what the problem with Prometheus is.
Yeah, so because Prometheus needs itself by itself, so it's a server which is responding to something that is collected and sent to it.
Mm-hmm.
So let's say if you want to log something in an Elasticsearch, then you have to send log to the Elasticsearch server.
Mm-hmm.
So it's similar. It is not clientless. You have to have client everywhere.
Mm-hmm.
So if you are collecting statistics directly from the charge ports, then it should also be installed in charge ports.
In the charging stations, the charging station itself, they are not in our AWS system, so they are physical stations, and the only thing that we know is if a station is connected and which request we send it.
I would like to know if you considered migrating to serverless architecture when you moved away from Cloud Foundry to AWS Managed Cloud Service.
Yes, we did. I'm just laughing because I'm now, since 3 or 4 months, I'm inside a project where someone else decided a couple of months ago to go serverless all the way. So I have some headaches sometimes.
Yeah, that's exactly what I want to know.
So I can share some insight from them afterwards if you want to. But the whole discussion about like should we go Kubernetes, should we go like plain EC2, ECS, Beanstalk, or maybe even Lambdas all the way, was that Lambdas, they don't really have so much support, I think at least, and we as a group decided from a tooling perspective, so like keeping all of them up and running and kind of orchestrating all the complexity that you have around them is a challenge today. And I would say a team of 4 or 5 people building something like this should probably go into something that has a little bit better support from the tooling today. This will change. Google and all of them will probably solve this for us in the future, but today it's not there, I would say. Kubernetes was a bit of a challenge in terms of it brings so much complexity, so we didn't want to like go into all of that from a concept perspective, and that's why we landed at ECS, which has this nice, you know, proximity to Docker, and you know, it's also very close to Cloud Foundry as well, since they are also a container base and they have this orchestration around them. So that's why we went ECS way.
Okay. I was thinking more on the lines that maybe you try to avoid vendor lock-in, which is also an overhead with a hosted cloud service with AWS. I see that there is more or less mandatory coupling that you have with the services that are hosted on AWS. So, okay,
yeah,
that's good to know. Thank you.
One of your keywords was
someone faster.
Behind you.
One of your keywords which captured a good crowd was React. We've not discussed React. Any comments on your use of React or latest use of React?
React we use as like obviously for our web applications for the operators to use. It was a little bit of a challenge to integrate this into our system because it wasn't there from the beginning. It came later after like we were quite okay 6 months with Postman, and then more people started to hate Postman, especially from the people outside of IT. So we built this web application, and we placed everything in this web backend for front end. To be honest, so all the React code is in there. And I would still say this is one of the monolith. And I've seen many architectures where the React app is the biggest monolith in the entire system, I would say. I haven't really found a better way, to be honest, to slice them a bit better. Or actually, I haven't experienced them yet. So that was a bit of a challenge to having this React application inside our web backend for frontend, because like this web backend for frontend has like 2 purposes. One is serving the React app to the client, and the other one obviously is a Spring Boot application that spins up and then just exposes APIs that the browser uses to like do its magic and fetch all the data. So it's like a bundle these 2 purposes together. So there's probably some potential to improve there.
I want to just chime in on the question for Prometheus. Perhaps my understanding was that the question is you have different environments like dev, QA, staging, production, and when you feed all this to Prometheus, how do you distinguish where it's coming from? So I simply think you're just tagging it with the environment and then you can filter for it.
Mm-hmm. Yeah, I think it's a label, isn't it?
The thing is, we have 4 different environments, and all these environments are in different accounts. And the nice thing is there that the live account Prometheus never gets data from the integration account Prometheus. So we have a clear separation here between the accounts. That's it.
One question.
And so if you have to start over again, so if you had the chance to start with a blank slate, what would you change? Is there something that is there because it's there? It's really annoying, but
yeah.
can you change it really?
To be honest, I think we would keep the costs more in focus because that's something where we didn't. From the beginning, we knew, okay, we have more or less a lot of money. That's not that our company has a lot of money, but they said, okay, this migration is so important, we have to do it now, and just focus on delivering that thing live. And now 2 or 3 months went on, and we just realized that the live account, for example, has only about 33% of the costs. The test environments have a lot more. And that's something where we have no concept for now, and which we definitely have to focus on in the next months.
So is it a one-to-one scale, so that...
It's a one-to-one scale between the live account and the integration account, so that we have a similar situation when we test there. But the playground and dev account, they are reduced in terms of database, in terms of availability zones, in terms of number of instances.
From the cost perspective, so compared to Cloud Foundry, was it similar there, or?
To be honest, I don't know what Cloud Foundry costed because we didn't get the billing there. So when we started the project, we were there in a pretty good situation for us because we could simply start developing and bring our services there to their system. And yeah, so the migration was kind of a shock for us because now we had to consider everything about improving our architecture, for example, in terms of do we really need all these adapters, do we really need 2 instances of everything running there, and yeah, that's the situation in which we are now.
And is it an improvement, so the step to AWS compared to Cloud Foundry? Which flavor did you use of Cloud Foundry?
So we had a self-hosted Cloud Foundry environment, which we did not self-host, and I would say don't host it yourself if there isn't someone else that hosts for you. I know there are big companies in Munich and around that have their Cloud Foundry hostings, and usually they have like big groups of engineers that are just responsible for setting up the Cloud Foundry environment. And I think Cloud Foundry is a super nice system if you have a central IT that can provide these Cloud Foundry environments, and then you just have development teams that can just use them on an application level. Similar to AWS ECS, so ECS is there, you pay ECS, and then you just deploy your containers onto this. And Cloud Foundry is a little bit similar. In the beginning, we looked into hosting Cloud Foundry ourselves because we thought, let's just have a look how it would look like. And I think Pivotal and Amazon, they have like a document, it's 70 pages long, and it explains you how to host Cloud Foundry on AWS. So it's pretty easy then not to do it if you read through this. So my advice is, as a company, don't host Cloud Foundry yourself unless you have hundreds of development teams. Then think about this because it gives you a nice abstraction there. Like back in the days on Cloud Foundry, the only thing that we did in our CI/CD pipeline was like a push application, and that was like CLI. CF push app, and then it was pushed into the Cloud Foundry environment, and everything was taken care of for us. So that was really comfortable from that perspective. But obviously, it comes at a fixed cost penalty, I would say.
So, but you don't want to change back?
No.
It would be for free.
No, I mean, the challenge with the Cloud Foundry environment is someone is running it for you. You don't really have so much insight and control into your networking. And one point is that charging stations, for example, are connected on a network level on secure WebSockets, for example. And we had some trouble like getting WebSocket connections into the Cloud Foundry environment, and we had to talk with a lot of people that were not inside our team. So that was a hassle in the beginning on the Cloud Foundry environment to get on a network level. As long as you're on application level, perfect. Network level, more difficult because you need to talk to other people. They need to whitelist you maybe, and then it becomes a challenge. Is it just you, your team being whitelisted, or the entire group being whitelisted, and so on? So for us, it's actually a nice way that we are now on AWS and have more control on the network layer also. As long as we want to, we don't have to, but if we want to, it's there.
Do you have some metrics of the system? How many users, how many requests? Are there peaks for performance where the system has to scale? And perfectly, maybe the impact on the costs?
Yeah, there's, you see, like one interesting use case for us is that we always need to support is that one person walks towards a charging station and then they need to authorize themselves so that the charging stations allows them to plug in their cable. So that's our main use case. And when do people do this? Usually when they drive to work, so it's between 6 and 9 and a lot of people plug in. First they plug out at home and then they plug in, so that's a lot of traffic, like authorization requests coming to our backend, and then we need to answer them, yes or no. And then at the evening again, when they return home and they have a home charger, and then they plug into their home charger, and then there's also a peak there. So it's in the morning and in the evening. But I think in terms of costs, I think we don't really need to scale up the EC2 instances of it or anything like this. So the EC2 instances are the same, even though the peak is a little bit higher in the morning than in the evening. We have a couple of thousand users probably. There are some edge cases like these aggregators. They work a little bit funny. They have like 50,000 charging stations across Europe, or across Europe, I think. And every time someone swipes their RFID card in front of one of the stations, obviously the stations nor the aggregator knows to which company this RFID card belongs to. So they send requests to every connected backend until the first one says, yes, that's fine, he or she can charge. So you get the traffic of every request that goes through the system.
Worldwide.
And, sorry?
Worldwide.
No, it's just from within this aggregator. But the aggregator is actually worldwide, focused in Europe, but worldwide. But obviously this system can't scale. Luckily we are not so on the forefront yet with electric cars, but if we were, then this traffic would probably hit a certain point in time where we would need to change in the industry this approach a little bit.
So how much requests?
Don't even know. It's probably like if you have like a couple of thousand users, once in the morning they plug in, once in the evening they plug in, and then you get these stations that send like every 15 minutes like, hey, I'm still alive, hey, I'm still alive.
So a bigger problem in that term is that we have a new type of stations. It's this also 1.6 stations that I said, and they have this secure WebSocket connection, and they send pretty much data. But the problem is they're not traffic. It's more a question about which of this data is really important, which of this data should we store, because we do not want to have millions of data inserts on our database when we don't use this data. Or another use case is there that the product that we are selling is something where we need to create in the end billings for that, and for that reason we have specific meters which are in the houses of our customers, and these meters they send their data to a backend that is not in our hands, but we have to get this data to create the billing. And that's also something where we get a lot of data that we simply do not want to have. So it's more about data and not about the requests.
Okay, you mentioned that you followed the basic rule of one bounded context, one microservice, one deployment unit. But I'm interested on how you organize the teams. Was it too small that one team would just do it, or you had several teams, and if several teams, how they communicated with each other?
I think, to be honest, I wasn't there in the beginning. I started 3 or 4 months after the project started. But as long as I'm in the team, we are one team, between 5 and 6 developers, up to 10 or 12 in the beginning, I don't know. And we all work together always, so there were no different teams. Only for the infrastructure, as long as we were running on platform.
I think it's something with WorldFace that hosting and customer data. Did you have any negative impact from GDPR? Normalization, scaling the backends, revoking the backends or customer records?
Basically a good question. That's something where we had a lot of talks about that. And the thing is, in our system, we are storing some kind of critical data in a way that you can always look up who is charging where, and you can follow the routes of the people. So, if you want to, but this data is not accessible for most of the people in our company, more or less only for the people in our development team. And if a customer, for example, quits the contract with us, then we are able simply to remove his personal data, and we can then anonymisieren the data. Yes. So in the end, we will have some charge detail records because we need to store them in terms of billing and things that come after 1 or 2 years for the company, but the connection to the real people is broken. And also we in the IT team are not able to get this connection back.
As you are running, let's say, 24 hours, 7 days, yeah. Do you make zero downtime deployment in your system? And this is a challenge for you?
We don't do it. There is a downtime of a few seconds in the system, but for the business case, it's acceptable for the moment, I would say. But it's definitely something to look into the future, to like have to green deployments or something like this.
Okay.
It seems we're running out of questions, but there were a lot of them. With regards to the bounded context, I just want to verify our current internal rule, whether that's fine with the audience. We have a similar but different rule. We have one bounded context can contain multiple deployable units or multiple microservices, and within one bounded context you should have one database. This could also be shared beyond microservices. So we flipped parts of the initial microservice definition into the bounded context definition. We have multiple deployable units in there, lambdas, microservice, and all of those things. And we have also the rule that one team can work in multiple bounded contexts, but not the other way around. So there should not be multiple teams working in one bounded context. Does this make sense for people?
Yep. Yes.
Okay, so now we have another question.
Actually, it's not really a question. I was thinking about it because I read Eric Evans about this DDD, and he was saying something similar to you, except maybe that these bounded contexts are made of aggregates, but each of these aggregates are database boundary. So actually one database would be by aggregate, and one aggregate would be a microservice. So the microservices running in one bounded context, which comes to what you're saying, and about the team split is exactly what you mentioned.
Thanks. So no more questions, and I hope you will not migrate to Kubernetes, but rather to Fargate, which would simplify the thing even more.
Increase costs by like 4 times or something?
Yes, and you don't have to manage EC2 instances. So that's. But this could be a separate discussion, microservice equals Kubernetes or not, but for a later talk. I believe we still have beer and pizza around, and give a big round of applause to those guys. They will stick around, hopefully. From the number of questions you had, are you interested in more of those show me your architecture like talks? So not the high level, the microservice guru comes and tells you how everything works in theory, but I show you the architecture and then we just challenge it.
Yes.
Yes. Okay. So you have an idea there. Yes. So we will. So if you have an architecture to show, it doesn't need to be the fanciest and shiniest Netflix-like architecture. Please ping me so that we might have perhaps a session where we show more than one architecture, continuously show architectures and learn from real-world experience. And otherwise, stick around, ask those guys, and drink beer. Have a nice evening. Thanks.